Okay, lesson 3.4 is talking about Bayes probabilities, and there is a formula that goes along with this, but I don't actually use that formula. I think it makes it a little more complicated than it needs to be. So I'm going to try to simplify it as much as possible. So in example 3.17, they talk about Marvin's Music places 80% of the special orders for CDs to a distributor in Los Angeles and the remainder to a distributor in New York. Special orders are always shipped next day delivery by the distributor, but they do not always arrive the next day. Shipments from Los Angeles are late 5% of the time, and shipments from New York are late 10% of the time. And they want to know if a randomly selected special order arrives on time, what is the probability that it came from Los Angeles? Okay, so here's how I would do this problem. I would not use a formula. I would use a tree diagram. I use a tree diagram for every one of these. And when I begin, in this particular case, I would think about where are these coming from. So the first thing they told me up here was 80% come from Los Angeles and the rest come from New York. So I would write them out as here's Los Angeles, here's New York. I'll write it like that so that I remember which one is which. And then they said 80% came from Los Angeles. So I would say this is 0.8 and this one would be 0.2 because together it has to be 1. So 80%, 20%. Then from there, they are either arriving on time. So I'll just put OT for on time. And then, or they're arriving late, one or the other, on time or late. So I'm going to do that for both of these, on time or late. And they said that shipments from Los Angeles are late 5% of the time. So late is 5% or 0.05. On time then would be 95% of the time. The ones from New York are late 10% of the time. So they're late 0.10 or just 0.1, which means 90% of the time they're on time. Okay, so there's my basic tree diagram. Now I would go ahead through and multiply these to get my totals at the ends here. So I went ahead and did that. Let me just write down what I got here real quick. This one I got, I'm going to write it out as Los Angeles on time was 0.76. And then Los Angeles late was 0.04. New York on time was 0.18. And New York late was 0.02. So there's my totals. Now here's where it gets weird. So they're asking me this question. They're asking if a randomly selected special order arrives on time, what is the probability it came from Los Angeles? So these are really like conditional statements. So like they're saying if it arrived on time, that's the condition, if it arrived on time. So I need to make sure that I am dividing by something. So what I always think about is I'm looking for this one, the probability that it came from Los Angeles and that it's on time. So let's look at that. It's Los Angeles on time was this. So that's 0.76. I'm going to divide that by the total that were on time. So in this case, that's 0.76 plus a 0.18 because this one was also on time, right? Okay, so that means I've got a 0.76 out of, that would be 0.94. And then I would try to simplify that as much as possible. So you can take a calculator, which I need to get. Hold on a second. Okay, so on a calculator, I would literally just type in 0.76 divided by 0.94, see what you get. It's a terrible decimal, so maybe see if you can change that back into a fraction and see what happens. So 38 out of 47 is what they're telling me. That's the simplest form. One way that you can do it also is just take the decimals away, so 76 out of 94, and then see if that simplifies, which is exactly what we did. Okay. The next one, this one right here, Clyde has a rather casual attitude towards his courses, and he studies for 1/3 of his examinations selected at random. In the past, he has passed 3/4 of his examinations for which he studied, and 1/4 of those for which he has not studied. All right, so the question is, Clyde passed his mathematics exam. Find the probability that he studied for it. Okay, so I would start out with this. He's either going to study or he's not going to study, right? So when I start out my tree diagram, he either studies or he doesn't study. So study or not. And then from there, he either passes the exam or he does not. So pass or fail on each of those. Okay, so he either studies and passes or studies and fails. Doesn't study and passes, doesn't study and fails, right? So those are all my options. So now let's go back and find those probabilities. So he said here that he studies for 1/3 of his examinations. So studies 1/3 of the time, which means 2/3 of the time he does not study. And then it said he passed 3/4 of the exams for which he did study for. So when he did study, he passed 3/4 of them, which means he failed 1/4. And then 1/4 of those for which he has not studied. So 1/4 of them when he didn't study, he passed. So he didn't study, 1/4 of them he passed, which means 3/4 he failed. Okay, so then I would multiply. So when I multiply straight across on this one, it's a lot easier than the decimals in my opinion. I hate decimals. I love fractions way better. So 1/3 times 3/4, I can cancel out the 3's and make that just 1/4. If I do 1/3 times 1/4, I get 1/12. 2/3 times 1/4, I can cancel the 2 and the 4 and make that a 2. So that's 1/6. You could have put 2/12. That's the same thing, right? And it doesn't really matter if you've simplified it. And then on this last one, 2/3 times 3/4, the 3's cancel, making it 2/4 or 1/2. Okay, so then the question was, Clyde passed his mathematics exam. So he passed. Find the probability that he studied for it. So the probability that he studied and passed was 1/4, right? So I've got 1/4 on top. And I'm going to divide that by the probability of him passing it just overall. Like, what are the chances that he passed it no matter what? So the chances of him passing here was 1/4 plus here was a pass. That'd be 1/6. So I need to add these together. Again, you can use a calculator or you can do it by hand. So 1/4 plus 1/6 gives me 5/12. So I've got 1/4 divided by 5/12. Or I could say this is really the same thing as times 12/5. Or I can just use the calculator and say 1/4 divided by 5/12. And that gives me my answer of 3/5. So 3/5 of the time, if he passed it, then he had studied. Okay. Remember, one of the most important things I think in this lesson is remembering what to divide by. And just remember this, you for sure are going to divide by a bigger number than what you are having on the top. Like the bottom needs to be bigger because you're definitely not going to get a whole number. You could possibly get 1, but you could never get anything bigger than 1. So if you get something bigger than 1, maybe you accidentally flipped your numbers. Maybe try the other one on bottom. Okay. Example 3.19, a faculty member at Gigantic State University regularly teaches an evening course in a neighboring city. Each time he makes the trip, he is randomly assigned an automobile from the university motor pool, because they have those. The motor pool consists of 50% Chevys, 30% Fords, and 20% Volkswagens. Some of the cars are air conditioned and others are not. Okay, so I'm in my head, I'm thinking about what is my tree diagram going to look like, right? So when I begin, it seems to me that he is picking between these three types of vehicles that they gave. They said Chevys, Fords, and Volkswagens. And then they started talking about whether or not it was air conditioned. So air or no air. Air or no air for each of them. Okay, so that seems to me like we're going to have a Chevy with air conditioning or a Chevy without. A Ford with air conditioning or a Ford without. Volkswagen with air conditioning, Volkswagen without. So now I need to go back and find those percentages that they told me. All right, so 50% are Chevys, 30% Fords, 20% Volkswagen. So they made this part really easy. 0.5, 0.3, and 0.2. That was all set up very simply. And then the air condition and not. So they said 60% of Chevys are air conditioned. Yeah. So 60% are air conditioned. So 60% right here, which means 40% are not. 50% of Fords. So 50 are, 50% are not. Volkswagens 30% are, which means 70% are not. I don't know in what world there's that little air conditioning. Okay, so then go through and multiply out your answers. Now, a lot of you can do this by hand, right? So 0.5 times 0.6, that's the same thing as 30%. I always just think of it as 5 times 6, so that's 30. So that one's 0.3. You could put 30 if you want to. So this one, 0.5 times 0.4 would be 20%. This one would be 15%. And then this one would also be 15%. This one would be 6, so that one is actually 0.06. And then this one's 14.14. Okay, so then the question was, one afternoon the faculty member is assigned an air-conditioned car. What's the probability that it is a Chevy? So what I'm looking for is a Chevy with air conditioning. So a Chevy with air conditioning was 30%, so 0.30. And I'm going to divide by, the condition was that it is air conditioned. So given that it is an air conditioned car, well, there was air conditioned right here, there was air conditioned right here, and air conditioned right here. I got to add all those together. So 0.3 plus 0.15 plus 0.06. Okay, so 0.3 plus 0.15 plus 0.06 gives me 0.51. And then again, I would just write it as a fraction. So I'm just going to take those decimals away, and that would be 30. Don't forget, if this was just a 0.3, if I take that decimal away from both of those and I write this as 51, this has to be written as 30, so 2 digits. So 30 out of 51. And I don't think that will simplify, so I think we are done with that one. All right, last one. So this last one over here is talking about a bucket labeled H and a bucket labeled T. And they are flipping a coin to see which one they pick. So the H and the T stand for heads or tails, so that's good to know. There's 3 yellow and 2 white balls in the H bucket, and there are 2 yellow and 1 white in the T. An experiment consists of flipping a coin once, and according to which side comes up, selecting 2 balls in succession and without replacement from the bucket. So this is like, that without replacement piece is kind of a big deal. That really changes your probabilities for each part. All right, so when I begin, I am either picking heads or tails. I'm either getting heads or tails, which is going to tell me which bucket I'm looking at. And then from there, in the H bucket, they had yellow or white balls, right? And I don't really care how many yet. I just know that I have either yellow or white to pick from. Same thing with this one. I have either yellow or white to pick from. Then I'm gonna, I need to think this through. I'm actually selecting 2, right? So I'm gonna have to, from here, maybe I get yellow the first time, but I still have a possibility of yellow or white again the next time. Same thing here, yellow or white a second time. Yellow or white, yellow or white. Okay, so I have the possibility of having bucket H and then yellow again. Bucket H, yellow, and then white. Bucket H, white, and yellow. Bucket H, white, white. And then tails, same thing. Yellow, 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 white, white, yellow, white, white. So there's all my options. All right, then let's look at our percentages again. So when I'm first talking about my heads or tails, they said an experiment consists of flipping a coin, a fair coin, once. If it's fair, that means it's a 50-50 chance for each of them. So I'm going to write it as a half. You could write it as 0.5. It's the same thing, doesn't matter. Then I'm going to select balls from these containers. So if you think about it, this first one, there's a total of 5 options for balls, 3 of which are yellow. So when I start out, I have 3 possibilities out of 5 that are yellow, and I have 2 possibilities out of 5 that are white. Now I want you to be careful on this next part. If I pick one yellow one, the probability of getting another yellow is down by 1 now. So I no longer have 3 yellow ones to pick from. Now I only have 2, and total I only have 4 balls left because I didn't put that last one back. Same thing here. So if I started out with the yellow, that means I didn't get any of the white ones. So I still have 2 white ones left, but I only have 4 possibilities total. On this choice right here, I still had all my yellows, so I still have 3 yellows, but I only have 4 to choose from. And then on this last one, I already chose one of the whites. Now I only have 1 left out of the 4 that are left. Okay, this one, same situation. So let's look at how many were in bucket T. I've got 2 yellow and 1 white, right? So if I have 2 yellow out of 3 total, right? Because I only had 1 white, so that means I had 1 white out of 3. So on this one, I had 2 yellows to pick from, but then I just picked 1. So now I only have 1 yellow to get out of 2, sorry. There's only 2 balls left because I'm not putting them back. And then white, I had 1 white and I haven't chosen it yet, but there's only 2 to choose from now because I took 1 yellow one out. On this one, I took a white one out, which means I only have 2 balls left out of the 2 yellow ones that I had, right? So this probability is just 1. Like I'm definitely gonna get a yellow if I picked a white the first time. This one, I have no options left for white because I already picked the white one out of 2 total. So this probability is 0. Okay. So the chances of this top one happening, I've got 1/2. I'm just gonna, whoa, what did I do? There we go. So I did 1/2 times 3/5 times 2/4. That gives me 3/20 for this option. And then for the next one, I've got 1/2 times 3/5 times 2/4 again. That's gonna be the exact same thing. The next one, 1/2 times 2/5, 1/2 times 2/5 times 3/4. That one gives me 3/20 again. And then 1/2 times 2/5 times 1/4, 1/20. Okay, and then on the bottom part, I've got 1/2 times 2/3, which I could do this just by looking across and multiplying, not a big deal at all, times 1/2 gives me 1/6. That one was especially easy because I could have just canceled out one of those, and then I just have 1s and then a 3 times a 2, which is 6. Same thing with this one. That one was 1/2 also, which means this is going to be the exact same probability. This one right here isn't going to affect this at all. So 1/2 times 1/3 is 1/6, times 1 is still just 1/6. This one is a big deal. This is 1/6 times 0. This is never going to happen, right? Okay, so their question on this problem, they had 2 questions. So part A said, if exactly one, let's zoom in a little bit, if exactly one white ball is drawn, what is the probability that the coin landed with heads up? Okay, so if I'm looking for white and definitely heads. So over here, I'm looking for a heads and white. Heads, and did they say exactly one white ball? So in this case, I've got heads and exactly one white, heads and exactly one white. This one is heads but 2 whites, so this one doesn't count. It's just these 2. So a 3/20 and a 3/20 would be 6/20. And then I'm going to divide that by what happens if there's exactly one white overall, not necessarily heads, because heads is that extra piece they asked me for. So I had the 6/20 already, and then what about this situation right here and this situation right here? Those were exactly one white. So a 1/6 and a 1/6. So I have the 6/20 that I had on top, plus I have 1/6 and another 1/6 for these 2 scenarios. Okay, so that gives me 6/20 over 6/20, let me zoom back out, 6/20 plus 1/6 plus 1/6 is 2/6, or I could have said 1/3, so that gives me 19 over 30. And if I divide those, 6/20 divided by 19 over 30, that gives me 9/19. Okay, part B is asking me for, if the second ball drawn is white, what is the probability that the coin landed with heads up? So the second ball only being white and heads is what I'm looking for. So the second ball being white and heads. So 3/20 and 1/20. So I'm going to say that's 4/20, or you could have said 1/5. But then I had a second ball being white here and a second ball being white right here. So this one was 0. That one doesn't matter. But I had another 1/6 right here. So I had a 4/20 and a 1/6 as an option for that second ball being white. Okay, so 4/20 plus 1/6 gives me 11/30. Okay, so 4/20 divided by 11/30 gives me 6/11. That's that probability. Okay.